one, but shh. What makes algebra algebra?
Numbers,
Letters.
Variables. Okay, the letters are called variables. Why are they called variables?
because they're just
There's never consistent.
they vary.
They vary in whatever.
Okay, the value of the letters varies from problem to problem. It changes on each problem.
What you
So, we didn't really do this in chapter 1, so now we're actually kind of starting algebra. Sometimes, yeah, this can freak people out. Variables just stand for a number that we don't know yet. It's kind of like a question mark. But there's a lot of stuff you can do with variables, while even if you don't know what it is. Okay, if it's not a, what's the opposite of variable?
Constant.
Constant, because it never changes. And what are constants in math?
0.
1, 0, yeah, numbers. 1, 3/4, 0.7, pi. Pi is a Greek letter, but it's always worth 3.14, blah, blah, blah. All right, so when you have some variables and constants together, this is called an algebraic expression. Anytime there's a letter in it, that makes it algebraic. So this is an algebraic expression. All right, so what is the variable in this expression? X. And what are the constants?
4 and 7.
Yeah, so, and if you add a little exponent, that's still a constant, okay? So the exponent is 4, 2, and 7 are all constants. Okay, actually before we jump into that, yeah, we should go through this list. What are some different ways that we can say add? You guys think of any?
Some.
The sum is the answer in addition. Plus, I'm not going to put that on the list, but let's assume you know.
I wrote all these down.
All together.
Okay, altogether, sometimes they'll say like the total. Not on this sheet, I don't think, but more than, increase by. Are you reading the book?
Definitely
Let's see. That's actually all I remember.
not. That's the only thing that's on there.
Yeah.
Greater.
Okay.
No, that's subtracted.
I know you were joking.
Yeah. Really, these and this one, those are kind of the three important ones. All right. What's some different ways to say subtract?
Difference.
Difference is the answer. If I take these two out, they kind of all have an opposite. So the opposite of sum is difference. The opposite of more than.
Less than.
We saw these a little bit in chapter 1. I don't know if you guys remember. Increase by,
Decrease by.
decrease by. Okay, out of all of these, now, does the order of addition matter? No. Does the order of subtraction matter? Yes. Okay, this phrase right here, I think we saw it twice in chapter 1. If I say, his age is 5 less than your age, how would you figure that out? His age is 5 less than your age, how would you figure that out? You do your age minus his age. So the reason I circled that one is because less than is actually backwards from how you say it. So I think on the homework from last chapter it was like 10 less than 5 or something like that. And some of you did this, but it's 10 less than 5 actually means 5 minus 10. So it was negative. Okay, so less than's backwards. The others are not. So if you say the difference of this and that, you just do this minus that. So less than is the only one that's backwards. If you say subtracted from, that is backwards, but I'm not sure that shows up on this. Let me. I don't see it. Hopefully it doesn't. Alright. Okay, what are some different ways to say multiply?
Product,
Product is the answer in a multiplication.
no, times.
Twice.
Times. Okay, yeah. Now I know you're reading the book. Yeah, twice.
Of.
Twice means times 2. Of me, when do we use of? It's kind of a weird one.
3 of 6.
No.
No, that's wrong.
It's used with percentages and fractions, like 3/4 of your age means times, or 75% of the people, that would be times. This is kind of an important one though, because this shows up a lot, especially in word problems. If you see of, it's usually a times. Yeah, twice means times 2. Okay. Division and divide by. I think there's only one quotient. Now, if you say half of, most of you would probably divide by 2, right? Half of your age is 14 divided by 2.
Yeah.
So that's fine, but it's also 1/2 times your age. So 1/2, multiplying by a half is the same as dividing by 2. Because what happens is that. So anyway, either way, it's the same thing. All right, let's jump in here. I don't know. You guys might like this lesson better. I like chapter 2 a lot better than chapter 1. Maybe you guys will too. We'll see.
Why is it a lot of easy work?
Okay, yeah. So Gracie, here's the day. Here's our assignment. Should be up there every day. It's usually almost always do the next day. Occasionally not. But I'll tell you if it's going to be a 2-day assignment. All right. So, any volunteers for number 1? All right. Savvy, what's the variable on number 1?
X.
I'll just do this. I'll do V for variable and C for constant. What are the constants on number 1?
3 and 6.
Okay, not hard to do, but if you get them switched around,
Oh, wait.
I believe that might be on the test too.
Oh, that's all it's asking. No, I would just
That's
solve
it. You can't solve number
Well,
1.
not to solve it, but to simplify
You
it.
can't simplify it either. You can only add terms together. Those do not add together. That will be Thursdays and Fridays assignment. Which way do we want to go?
I would say
We'll go this
Would
way.
pi be a variable?
Pi is a constant because it's always worth 3.14. Okay, Hallie, on number 3, what's the variable? The variable on 3? T. And the constant? That's your speed. All right. Number 5. Now I'm not going to mention this again, but I'm not going to limit calculator use going forward because that's not really that's more like 5th grade math, like multiply, divide by hand. So anyway, we reviewed it. Now we're moving on. Number 5. Trace, are you still working or are you done? Okay, let's Keegan. I should explain this. It says evaluate each expression for each member of the domain. Okay, the domain, that's a fancy word of saying all the possible values that you can put in for x, or whatever the variable is. So the domain just means the possible values that you can plug in. So basically what they're saying is we're supposed to plug in all those values in the directions. And the direction says -4, 1, 3, 8. So we're going to plug all those in That means each of these answers
Different.
is gonna have 4. Each of these questions is gonna have 4 answers. Okay, so on number 5, it says x minus 4. So I'll do this one. You guys have done this before, I'm no doubt. But, so that's what we're gonna plug in. So number 5 is basically, the first one is negative 4 minus 4. All right, so that would be negative 8. Okay, and I'm just gonna keep going. Plug in the 1. So Keegan, 1 minus 4. And then plug in the 3. 3 minus 4. And then 8 minus 4. Yeah, so make sure you have all 4 answers there. I'm not gonna make you show your work yet. Eventually I'm gonna make you show a lot of work, so enjoy it while you can. When we start solving equations, you gotta show your work. Number 7. Alright. So Austin, what's it mean when it just says 3z? What does that mean?
It's 3 times 7.
3 times z. Well, that's, pretty much always when a number is right next to something, it means multiply, yeah. So the first thing we do is 3 times negative 4.
That'll be negative 12.
And 3 times 1. And 3 times 3.
9
And 3 times 8.
is 24.
Okay, even though you have a calculator and I can help you get all these, imagine how much time you could save if you knew the times tables. It makes life a lot easier in math, and especially down the road. Anyways, number 9, so Joe,
Chase. He said he moved to next.
Chase 1 and 2. You afraid of 1/2? Well, we kind of talked about this. What's multiplying by 1/2 the same thing as? If I said half of your age, what would you do? Divide by 2. So yeah, like what was the first one? Negative 4. So what happens is negative 4 is like negative 4 over 1. So it basically just divides by 2. So yeah, it'd be negative 2. And so if multiplying by 1/2 is like dividing by 2, what's multiplying by 1/3? It's like dividing by 3. How about multiplying by 2/3? It's like dividing by 3 and multiplying by 2. Okay, just for future reference. Okay, anyways, let's keep going. What was the second number? 1. So what's 1/2 of 1?
25.
Yeah, or just 1/2. Anytime you multiply by 1, it's gonna stay the same. 1/2 of 3.
1.5.
Okay, I would take that. Normally, though, we'll just almost always, unless it's like a decimal problem, we'll just leave it in fraction form. So it is 1.5 or 1.5 or 3/2. I'm not gonna count it wrong if you don't write it a certain way, but that's how the book writes it. I just can't stick with it. And then 1/2 of 8. Okay, now here's starting on 11 to 12. This is where I think we'll start to miss them. So on number 10, what are we supposed to do?
Negative 4.
You divide by 4, and then you add 5. Divide by 4, and add 5. So 11. All right, this is an important note. So can you guys listen for a second? X squared, if I plug in -4, what's that gonna become?
Positive 16.
A lot of us missed this on the test.
That'd be negative 16.
Okay, if I write it like this, that's -16, because you square the 4 first, kind of order of operations, and then you add the negative. Okay, so the 4 is squared, but not the negative. But if you have it in parentheses, that's squared. Now, are we supposed to just square the 4, or are we supposed to square the -4? We're supposed to square -4 because we're squaring x. So we're actually doing this one right here. So if you use a calculator and you put it in like that, it will be wrong. If you put it like this or do it in your head like that, this will be right. Okay, so this is supposed to do -4 times -4.
Which is positive 16.
Yeah. And then over here we have 4 times -4. So, Chase, this will be positive 16. What will this right here be?
4 times -4 is -16.
So we have 16 plus -16.
0.
Yeah, notice I am using order of operations, but your calculator did that automatically. And then if we plug in 1 squared is 1. 4 times 1 is 4. 1 plus 4, 5. Whoops, started doing the next problem. What was the next thing? 3 and then 8. So 3 squared plus 4 times 3. Chase, what's 3 squared?
9,
4 times 3?
12.
9 plus 12 is 1. Okay, and this one is larger. 8 squared is 64. 4 times 8 is 32. 6 plus 3 is 9. 4 plus 2 is 6. I like to circle my answers when I show work. It makes it really easy to find the answers for you and for me. 13. All right, next section. Let's see where we're at. Caitlin, it says translate each word phrase into algebraic expression. What does the product of 8 and a number mean, Caitlin?
8 times n.
Right. Now, what's the best way to write 8 times n?
8x.
Okay, just put it right next to it, right? That means multiply. Now, does it matter what letter we use? No. Sometimes they tell us what variable to use, but you can use whatever letter you want. Okay, can I solve that?
No.
No. Okay. I mentioned this in chapter 1. It kind of showed up again. Did they put this in the box? No, they didn't. Oh, yeah, they did. Okay. Less does not mean the same thing as less than. Okay, in chapter 1 I said I've never heard anybody actually use this in real life, so you can kind of ignore this. I guess the book used it again though. So 15, I'll just say this one. N less 10 just means n minus 10. If it was less than, which is very much more likely to see, it would be 10 minus n. So the order does matter on those, but the word less by itself just means minus. All right, Bailey, number 17, 4 more than 5 times the number. What are you doing?
That's 5.
Huh?
She's with Mr. Cloud.
No.
Marta's mom's had that. She's had no. You know, I thought she was thought. Kind of want to walk off, see what happens.
Okay.
What if she was to be like Alex last year and jump off the window?
All right, Bailey.
So 5 times the number, 5 times n, plus 4.
Right. 5 times the number and 4 more than that. is the same.
Oh, so
We have 3 weeks in, boy.
Gosh darn.
What you do?
I'm just kidding. It's fine.
Mine's a bit
Jump here.
All right. Okay. By the way, does the order of this matter? Could we do 4 plus 5n? Is this the same thing?
Yeah.
Yeah. Order of addition does not matter. So these would both be okay. Okay. 19. Shh. 19. The difference between. So Ashlyn, do you remember what the difference meant? Do you remember what difference meant? Right. So what are we subtracting? The difference between a number and twice the same number. Close. In. What does twice mean, you know? To what? If I said twice your age, what would you do? Times 2, right? So, if I said twice a number, how would I write that? 2 times the number is the same as this number. So, if it says a number, that means the variable that we're not sure of. So you just put 2 times n. So that's twice the number. And it said the difference. So remember, you said subtract, which is right.
Why does it smell like that?
Okay. Ben. Nope, I'm on that one. Well, yeah. You guys don't know this one, I imagine. Q to the 5th power, what does that mean?
Cute.
Ben?
I mean, I think it's cute for the 5th.
Yeah, it's Q with the little 5 on the exponent. It's kind of hard to say that a different way. All right, let's see, where are we at now? 23. It said translate each word phrase. This is kind of the same thing, but this is more story problem-ish. But it's kind of the same thing as the last section. So, Riata, it says, the calories Joe consumes eating
That's rough.
That's crazy.
in sweet rolls, when one sweet roll has 325 calories. So, if you're eating a bunch of rolls, and you know how many calories each of them were, how would you figure out how many calories you ate, Rihanna?
Together.
You want me to repeat the question?
No, thank you.
Okay. Do you know what I said?
No.
Okay. If you're eating a bunch of rolls and you knew how many calories each of them were, how would you figure out how many calories you ate? Let's say you ate 5 rolls. How would you figure out how many calories you ate? Okay, let's say, let me make it smaller. Let's say each roll is 100 calories, and you ate 3 rolls. So how many calories did you eat? And how'd you do that? You did 100 plus 100 plus 100? Or times, yeah. So, syndrome. So, if each roll is 325 calories, and you ate, did they say in rolls?
Yeah.
In sweet rolls? How many calories did whoever eat?
Joe.
How many calories did Joe eat? Was it actually a Joe?
Yes.
Yeah, it is. Did he know?
Are you solving or are you just?
Stop.
I don't know. What's he
I'm talking to you.
Oh, sorry.
So, remember you did 3 times the number of calories in each roll. So in this one, they're saying the number of calories in each roll is in. And they ate, how many rolls did they eat?
It doesn't say.
Oh, it's the number of calories they ate. So anyway, you just multiply them together. So 325 calories times the number of sweet rolls.
I'm not fitting.
Okay, that just means multiply, right? All right, number 25. All right, Isabel, the number of history books in a store, if there are 4 more than 3 times the number of math books. 4 more than 3 times the number of math books. So what's the variable on this one? What's the number we don't know?
How many math books?
Right. So you have to make up a variable for that part. So we need 3 more, or no, it's 4 more? 4 more than 3 times the number of math books. How do we write that? What's 4 more than mean? Let's start with that.
4 more.
Mm-hmm. So you could say it's 4 plus, and then 3 times the number of math books.
Would it be into the third thing?
No, that would, exponents are different than multiplying.
So you just do, wait, 3 in?
Yep. Yep, 3 times the number of math books. And yeah, does the order of addition matter? No, so we could have written it like this as well, plus 4. All right. Oh, did I stop there?
Wait, so we don't solve
Yep,
these?
20.
Oh, wait, no, never mind.
Oh, darn.
Oh darn, looks like we gotta start doing our even stuff.
I think he said after class, didn't he?
Yeah.
We got that